Every time you board an airplane, you're sitting beside one of the most important safety features ever designed. The window. It seems like such an ordinary piece of glass. But have you ever wondered why every airplane window is rounded? That simple curve exists for one reason. Because square windows once caused airplanes to rip apart in midair. Let's go back to the early days of jet travel. Back then, airplanes flew lower and slower. Cabin pressure wasn't nearly as demanding, so engineers had little reason to question the shape of the windows. In the early days of aviation, windows were square. But a hidden law of physics turned those sharp corners into ticking time bombs. Britain took the lead with a revolutionary aircraft, the de Havilland Comet. It was the world's first commercial jet airliner. It flew twice as fast as existing propeller planes and cruised high above the turbulent weather below. Flying higher was the ultimate goal. The higher an airplane flies, the thinner the air becomes. Thinner air means less drag, which means less fuel consumption and faster travel. It was a massive win for airline economics. But flying high created a massive engineering challenge. Pressure. Humans cannot survive at 35,000 feet without oxygen and atmospheric pressure. To solve this, engineers pressurized the cabin. They pumped compressed air inside the airplane. Then, the unthinkable happened. In January 1954, just 2 years after commercial service began, a de Havilland Comet took off from Rome. It suddenly vanished from radar. It had torn apart in midair, crashing into the Mediterranean Sea near Elba. All 35 people on board were killed. Months later, a second comet also crashed into the Mediterranean Sea near south of Naples, Italy, shortly after departing. Investigators searched everywhere. Nothing explained the crashes. Later, engineers built a gigantic water tank and placed an entire comet fuselage inside it, then repeatedly pressurized it. Eventually, the answer revealed itself. Tiny cracks. How could something as ordinary as a window destroy an airplane? The answer lies in a concept engineers call stress concentration. Imagine a river flowing smoothly down a straight path. If you place a round rock in the middle, the water flows smoothly around it, but if you drop a sharp, solid square block into the path, the water slams into the corners, creating pressure. The same thing happens to force inside an airplane cabin. Round windows don't allow stress to build up in one spot. Instead, the force spreads smoothly around the entire frame. Just an even distribution of pressure. That one design change transformed aviation safety forever. And if you've ever noticed the tiny hole near the bottom of the window, that's there for a reason too. It's called the bleed hole. It allows air pressure to equalize between the inner and middle panes. Even something as small as that tiny hole has an important purpose. More videos coming soon. Subscribe to stay tuned.